Welcome back, people, to our third session, first day for this preparation DP 203. I hope you had a great day yesterday or evening. And today, well, I should say maybe good evening, good day, good morning. As for me, it would be a good day since it's still the morning. And to pursue with our course, with our course of DP 203. Today we're gonna check again. We're gonna see two modules, and the one that you can see here would be about exploring, transforming, loading data into the data warehouse using Apache Spark now. And the second module would be about the Azure Data Factory. And we are still then going to talk about this ETL process, right? That's what we started yesterday, talking about the ETL process, remember, within Synapse Analytics. And here we're gonna just also have a look about what's going on with Apache Spark, especially when we want to load this data into a data warehouse. Maybe I could even just make a quick remind later on, what about those data warehouse? Because I know some of you guys might be a bit familiar with that, not all of you. So maybe it would be a good thing to also check again, what is a data warehouse, how it looks like, what for, etc. After all, we're here to learn as much as possible, right? So, okay, I'm gonna introduce you that module so you will be able to load those data and make any exploration, transformation actions of there using Apache Spark, because Apache Spark, as I mentioned previously, remember that technology as something, all right, it's open source, right? Apache, as many of you may already know, Apache is an organization, open source organization, at the contrario of commercial organization like Microsoft and any others, right? But Microsoft is leveraging some technology of the open source world, which is quite more and more common nowadays to do that because we don't want to be as isolated. The open source world is very important in the IT world to leverage and to have always at hand because that's where many innovations are done. That's where you can actually spread and make use cases of many features, capabilities. That's what happened here with Apache Spark. Apache created, again, as I mentioned previously, this technology Spark to handle big data, okay, big data analytics. That's what it is for. And I'd like to mention again and again and again because many new terms and words are coming up in this course. So some of you might be a bit confused with all of that. And I perfectly understand. It is perfectly normal if you have not been in this field previously. As a Sam, it happened to me. So yeah, it's always good to remind you, and I'm trying to give you here some little tips to focus on some mnemotechnics things. So again, when you see Spark, Apache Spark, then think about big data analytics. Okay. We will start actually, yeah. So we talked about the Spark technology. It's a agnostic technology at the first level, and we will actually see how this is a specific component of Azure Synapse Analytics in how it can help you to work with those actually big data engineering workloads as this technology is intended to do. Later on, we'll focus on working with some Apache Spark clusters, again in Synapse Analytics, and how we can interact using notebooks. I will not do any demos since you will have the labs at your disposal, so I will be focusing here on the theoretical part. And this use case, actually using the notebooks, will show you how to explore transforming data and using what we have already seen a bit quickly, data frames. Okay, data frames, and it's a very, very important concept here, or let's say an object, right? It's an object in Apache Spark pool within Synapse Analytics. Okay, so yes, we will then explore how to integrate data from a Spark pool into a dedicated SQL pool. Okay, that's the purpose here in this module. So again, in the lab, you will have the opportunity to explore the data stored in a data lake, transform those data, load those data into a relational data store. Okay? You will interact with many types of files like Parquet. Parquet is a very common file for this purpose. JSON files, and how to query those and transforming those JSON files that has actually a hierarchical structure. Okay, remember the JSON files are semi-structured data and they can have many levels of hierarchy of data. Um, Maybe I will try also to show you an example of a JSON file to make you understand what we mean by hierarchical structure. And that's very fundamental here because when you have those type of files with a hierarchical structure, then you will need to process those hierarchy levels, flatten them so you can process that and get that into your SQL pool, right? All right, so without any further ado, let's review the agenda what I was talking about. First, big data engineering with Spark, okay, in Synapse Analytics, ingesting those data using Spark notebooks. And that's very also interesting thing here, notebooks. I mean, not all of you maybe already worked with a notebook. It's not a notebook from the one, the PC, the laptops, the some brand of laptops. No, notebook here refers to, let's say, a framework or an environment, even an environment where you can develop and implement your code, visualizations, etc. Again, in Synapse Analytics, then again, as I mentioned, we're gonna try to do some stuff like transforming data with those object of data frames in a Apache Spark pools of Synapse Analytics and integrate SQL and Apache Spark pools in Azure Synapse Analytics. So that's the agenda for this first module of today. And let's jump in on the first lesson, which would be understanding big data engineering, and obviously with Apache, leveraging Apache Spark in Synapse Analytics. And I should say, actually, anything that you can see here about Apache Spark applies the same in Databricks, right? Because we have seen a bit Databricks yesterday. And I guess, yes, we have overviewed the architecture of Azure Databricks. Remember, with the data service integrations on one side, on the other side, the machine learning capabilities, and how the runtime environment were supporting those functionalities and modules. So here we are in Synapse, right? But on the Spark module, and it's the exactly same thing in Databricks about Spark. So that's what we will not repeat for Databricks. Okay, whatever you see here in Synapse Analytics is the same for Databricks. And again, I'd like to remind you, as I mentioned a bit earlier in the previous modules, that Apache Spark is a parallel, and it's very important to get that, to keep that in mind, parallel processing framework. Well, I actually might have mentioned about the parallel processing, um, a massively parallel processing uh, tool, right? Because what it means here is that you're gonna take your bunch of data, right? Your bunch of big uh, data, right? Very big. And actually, may I mention here quickly that some of people in IT are maybe considering big data now. I mean, just like uh, some people, right, that in organizations that are considering like now, as per today, 90 petabyte will be considered. I changed the color. Yeah, 90 here. Petabyte would be the, let's say, break-even point or the threshold where you start to talk about big data. Under that, I think it's petabyte, right? Not terabyte, definitely not terabyte, because terabyte is not enough. Would not be exabyte because that's very much. So yeah, it was, yeah, petabyte if I'm not wrong, which means like 9,000 terabytes, which is not so bad. And this threshold would be considering like, okay, from that point you are talking about big data because of processing. How can you process so much data? Uh, in the previous years, that was obviously less. And that's a very relative threshold because depending on how capacity of processing data, that's where you're gonna use the parallel processing framework. Because again, as I mentioned, if your compute capacity cannot process or doesn't give you the let's say time requirements that you are expecting when you are querying something, it takes too much time, then you need to, well, divide to conquer. You probably have heard about this lemma, divide to conquer. It's the same thing here. You have to take your whole bunch, your whole chunk of big data and divided it and to get, well, to get it done, to process it between many executors. And you're gonna see on the next slide what I mean here by executor. So again, not to be lost in our explanation of the why of getting this architecture here, parallel processing. Um, Again, it's an implementation here done in Synapse in a conjunction of Microsoft and Apache organization in the cloud, right? So it's a special conjunction here, let's say like a joint venture made here. So something also worth to mention, Spark pools in Azure Synapse are compatible with the Azure storage and Azure Data Lake Generation 2 in particular. So you have the blob storage and you have your data lake. And should I say even the Generation 2? Now, again, I'm gonna give you here a tip. What about Generation 1 and compared to this Generation 2? Like something where upgrading, they upgrade something? Yes. Data Lake Generation 1 is, oops, again, I did something wrong here. Okay. The Generation 1 here, right? Junction one is actually the data lake based purely on block storage, nothing more with a flat space, namespace actually. Generation two, on the other hand, is the upgrade, yes. Why and how? Because those block storage are now with a hierarchical namespace. So that means you're gonna have some hierarchy with nodes, with names on nodes. Like, should I mention? Well, just like a very quick hierarchy here. But on nodes here, it could be like, for instance, the time, like year, 2000, let's say, here we are beginning with the root, but here it will be 2019, 2020, and then 2021, etc. And under this level, this layer of year, you can have a month. And again, you're gonna have 12 here, 12 here, because you have from January to December, and so on and so on. And that's actually a typical hierarchy of time done, right? So as soon as you can do that, you have a data lake stored generation two. It's always based on blob storage. Blob, blob is like a container again where you store big files, binary files, whatever files you want to store. It can be CSV, Pocket, etc. So that's like a very flexible container, let's say. Um, Now, regarding the layers, you can see here. Um, what you need to also here take into account is the Spark core engine. As I mentioned, is a distributed execution engine. So it's gonna, as I mentioned, um, put your work, distribute the queries among over nodes. On top is distributed execution engine. You can have different functionalities that can interact with the Spark core engine, and you will add those core engine as required. And here you have an example like Spark SQL, like Spark Elm Leap for machine learning. So this is like querying functionalities. There are machine learning functionalities, so get patterns, how the machine can actually, for instance, make the facial recognition. That's purely machine learning stuff. And also GraphX, graph computation, over capabilities here that I will not then get into because it's a big topic. Yarn means yet another resource, should be actually management Elm, but this layer actually here is the one responsible to get the distribution from the core engine to get to the resources. So that's why it's just in between with the storage layer here. It's gonna data, it's gonna distribute the data you want to process for your querying or for any work you need to do, any workload. Okay, so that's the architecture. There are different layers, right? Ones that are making the decisions, here about the capabilities, and here about the management as per se. Like, okay, I need this query processing, process this query. So this layer with those layers here on the storage level will get the things done. Now, here it is actually what I was talking about, right? About what's going on with, let's say, your cluster manager getting with some nodes, right? With cluster, with nodes in the Spark pool. And those are the executors that are going to process the query. And the cluster manager is the one who is getting the order. Remember, it's actually the same architecture I've already talked about yesterday, but we're gonna review that again today. So you're gonna have it very maybe clearly anchored in your mind. So Azure Analytics, well, Azure Synapse Analytics get with Azure Spark application those independent sets of processing in a pool, right? Everything is coordinated by this Spark. Let's say we can call the cluster manager here the Spark context. Okay, it's a Spark context object that will drive, right? Will drive here. Actually, the Spark context at this level here, and he will get into a cluster manager. And the cluster manager is nothing more, nothing less than what we have seen previously, the yarn level, the yarn layer based on Apache Hadoop. Okay, now let me put it here. So you have here the Spark context getting into this cluster manager, and this is um, the yarn layer, and it's based on Hadoop. Again, another word here, another technology. Hadoop is something that allows you to manage big data. Okay, it's a system, file system for big data. And as it's big data again, it's distributed. We the paradigm for big data is definitely another that the ones you can usually see when you are working with more maybe traditional, let's say, programs, applications. Here we are in a distributed architecture. Distributed, okay. Once connected, the Spark acquires executors. Okay, we're gonna acquire those executors. We're gonna look for it, and you don't necessarily know which one we're gonna be. But here, this cluster key manager will actually look for those executor for nodes. Okay, in a dedicated SQL actually pool, you know how many you're gonna use. In a serverless, you don't know, but you don't know the identity, maybe should I say. And so they're gonna run the computation and store the data again. Here you have this link because those executors are gonna store the data application. And finally, it's gonna send your application code. So it can be done by, for instance, Python. Python again is a language to implement your code to the executor. Okay, so Spark context here sends the task to executor runs and get back the result. And everything is done with those layers here supported or underneath with the data lake. Okay. Um, what are the benefits actually of having a Spark pool in Synapse? So some of them are, let me list it here. For instance, speed and efficiency. Why? Because for instance, when you want to launch a Spark instance, it can take you approx 2 minutes. 2 minutes when you have fewer than 60 nodes. Okay, maybe I'm gonna put that here again. 60 nodes. And on the other side, it's gonna take you about 5 minutes if you are more than 60 nodes. So again, that means what I've just said. If you have those nodes here, like less than 60, to launch your workload, 2 minutes. I mean, it's a great performance. And if you have like 60 of those blocks here or more, then it takes you 5 minutes to get launched your workload and spin it off. You have to be in this field to have you have to had to work with this kind of technology and getting big data done to really realize that you are talking about very great performance. Okay, speed, efficiency. Another one would be, sorry, here we go, would be ease of creation. Ease of creation, and it's gonna actually include some preloaded preloaded uh, libraries, so you don't have to take care about implementing and downloading any libraries. Actually, for Python, it's gonna be, for instance, Anaconda library. So those library, what it's why do you need those libraries? Basically, to perform the tasks that you want to perform when you're gonna launch and spin off those nodes. And believe me, again, as it includes lots of things, the way of create those nodes, I mean, the link at least here is something that will you will be very thankful. Uh, you don't need to have a big technical and sharp knowledge about how to configure and to prepare, to provision your node and to launch them and to get them work together. Here you can see. Another one would be there is a support, and actually it supports the Azure Data Lakes Generation 2. Okay, so again, you don't have to put any layer in between, so the things work. So you just have to specify what is the path of your data lake store, and that's it. You will be connecting to your data lake storage. It's very simple to do that. The scalability is another benefit. Scalability, again, it means you can scale. So that means you can um, get your big data at the size you need it, right? For instance, today you are working with, I don't know, 100 petabytes, and tomorrow, you're already thinking about tomorrow, and you need 10 times that amount of data or space or storage, then you can scale it at that point, right? And you have an option that actually is auto scale, so you don't have to be worried about later on to rescale your capacity. And as we were talking about how easy it is to create those things and spin it off, here, for instance, an example, a screenshot of how to create an Apache Spark pool. You have different sections, but the very important one is in here always basics. Then you have additional settings, tags. Tags is something you would use later on for an administrative purpose. Uh, Generally in Azure ecosystem, in Azure portal, when you're creating your resources, you have usually these tags. And at the end, you're gonna always have review and create. This part is when you want to make sure that what you're creating here is consistent. It makes sense. And that's where you're gonna click there, and um, Microsoft will tell you, all right, makes sense. You have the green light, or red flag, something is wrong, and it's gonna tell you where you need to pay attention and to change the things. So back to the creation here, you have a little description. Always provide a name. Usually the name you need to provide for your resources needs to be unique on the global level. So that means unique within the whole Azure ecosystem. ecosystem for everybody. So that's why sometimes your name are gonna be a bit barbaric with lots of letters and numbers because they need to be unique at the, let's say, Azure directory, but the global one. Here in this case, as we are talking about Spark pools, you need to consider the node size. So that's what we were talking about previously. How many, for instance, cores you need? Here, 4 V cores. That means 32 gigabytes of internal memory of those cores. And you can enable the auto scale, right? So you don't need to be worried about to rescale it, but beware. It means that at some point you can lose control about your, let's say, costs. If you're using more than expected and you know about that, then this option can actually be a bit problematic later on for your accounting department, and you might have some surprises. Here is about actually setting the nodes, because here are the type of nodes for vCores, right? But the number of nodes is here actually. How many nodes you need, right? Here is, for instance, set for free. The minimum, I guess, is one. And it's gonna give you here an estimated price, right? Why estimated? Because it depends really of the amount of data that are gonna be processed. So you don't know yet the exact amount of data that are gonna be processed. Yet you have here the capacity, but anyway, it can be a bit more, it can be a bit less about what we can estimate here. So that's why it's estimated. And you're gonna have a link to see the details about that. I guess I've through here the main things you need to know, right? And again, in the lab, you will have opportunity to provision your Spark pools. Lesson 2. Let's talk about ingesting those data with Apache Spark. Okay, I see here no questions. Perfect. So we're gonna talk about also the Azure Spark, sorry, Azure, yeah, the Spark, Apache Spark notebook in Synapse. Okay. So what about these notebooks? Okay. Um, the benefit of using actually one of the benefits of using Synapse Studio environment is having those notebook available. Okay, and having those notebook available gives you flexibility in scaling when you use those notebooks. So scaling up or down between notebooks is possible, and writing in notebooks in multiple language, Python, Scala, R, is possible. You can pass through the keys, right, through those languages, and therefore the data sets that you are working with. Okay, so doing that is very, very comfy, very, let's say, good, because you don't have to switch tools. You know, when you use when you want to write here something with Python, and so suddenly you were considering something in Java, or then in Scala, and then you don't need to switch your environment. You can actually get a cell, because notebook is working by cells. Okay, here is the cells one, then you have cells two, etc. And you just write your code, you type your code, and you type anyway the descriptions, or then you can type some codes to make a visualization of your data set. So that's very, very useful on that endpoint. Okay. What should I say also? Yeah, you can create many as many notebooks as you need. So you're gonna have many examples if you go on Microsoft Knowledge Center, right? Changing one thing to note, just for you, try to remember because it might goes and might be on the exam. When you want to change the language, you can just put those two percentage sign, and then you name the language you want to go in. Um, it offers also temporary table of cost languages, and you can export the result. Okay, so here is how it presents. Not this one. Oh, sorry. Yeah, that was the one I was looking for, the Zoom. Okay, so here we go, right? Attached to one thing also you need to know is you're gonna need to attach a notebook to a cluster. Okay, this is a cluster here, Spark Spool Synapse. Let's put it here. Attach to a cluster. As soon as you have a notebook and a cluster spoon off, then you need to attach it. If not, it doesn't work. So that's one thing you need to consider. Um, Notebook cluster. Think about that. And change the default language you want to use. Okay. Um, Let me here just double check something. Okay. Regarding the chat. Okay, we're going well. We come back to the process here, how to create this notebook in Azure Synapse Analytics. The process are quite the same in Databricks, but here you just have to know with this GUI Synapse, you have different here options or sections: home, data, develop, integrate, monitor, manage. This goes to really the Synapse Analytics, let's say, knowledge, how to use the GUI, the Studio Synapse. But just you to know, when you want to work and get something to develop, as it says here, you go on develop section. Integrate will be more what we're gonna talk later on when we see in the ETL process, extracting, transforming, loading data. This will be in this section. You want to monitor also sometimes your pipelines or what you have developed, and you want to also manage your assets. And data is about data sets that you might have considered data, any data sources, any data sets, etc. Homepage is where you start, right? But again, okay, let's come back here into the develop section that where you're gonna be able to create your notebooks, okay? And you just have to yeah, click on the plus sign here and get a new notebook. And you don't need to provide any secret keys here. No need. I mean, maybe you don't have any clue about what is a secret key, but just so you to know, um, the notebook is something that needs to be secured. But in this case, secret key is no needed. You can configure the Spark pool by changing the Spark session per notebook. That's something available. And you can specify when the session should time out, how many Spark executors you would like to use, as well as the size of the executors. Remember those nodes that are executing your work? You have the flexibility per Spark session to configure the compute resource that you're gonna need, okay? So that's something also important to know when you are getting into the notebook configuration. Then here we go. As soon as you do that, you're attaching your notebook to a cluster with a language, Python in this case. You go on the properties, you specify the name, you can put a description. Um, and definitely you're creating a blank notebook here, right? And the notebook again is configured or is laid out with cells. You have cells 1, cell 2, cell 3, cell 4, and they are linked. So anyway, you do anything you do here in cell 1, you can have the result, the output. It's stored in your memory, and the cell 2 can reuse that, and so on and so on. Okay. And again, a notebook, one of the advantage also is because you are getting out of the layer of languages. So you can use different languages, you can use different contexts. So that's a good thing using notebook. Here we have an example, generating data. You execute this command here, right? PySpark, so Python. PySpark is a library of Python. Python developed this library for Spark technology. And here is an example. You have a list here of values. Then you're creating here a data frame with the method. Again, method, remember, you have your Spark object from your library of PySpark. Okay, if you don't include this library, you cannot use this object Spark. And this method also is within this library. So create data frame, then you get here new rows, this list here, and you are specifying here the attributes here, states, age, and salary. Okay, which correspond here. For actually, you can see state, for instance, California, Washington, if I'm not wrong, or Wisconsin. No, Wisconsin is number one. It's Washington should be. Again, Washington, the age would be 22, 35, 50, and the salary 45K, 65K, 85K, which is quite decent. All right, and finally, you have here your demo PDF, the data frame show, which can display your data frame. HTML mode display would be, or maybe vice versa. Is display method or in show method. Display one is maybe in the HTML format and show command line format, or vice versa. Okay, so here you are displaying your rows. So it's I'm taking this opportunity to explain you a bit how actually this works here about Python PySpark, but it's very straightforward if you know the syntaxes. Loading data in a single command for the file, so you can actually do in one command loading data. So here's an example. Even the data frame, you use this combined method, this chained method, sorry. And I guess we have seen that yesterday already, but you use your Spark object, then you chain the read and load methods, providing again the path of your data lake. And finally, you can display that with a limit, because if it contains millions of rows, you don't want to display those millions of rows. Um, that was a single example here. Again, and it's always good to see again and again the examples to repass the thing, because believe me, new concepts needs time to get into our mind and to get fixed there, anchored there. And we jump into the third lesson now, transforming data with data frames. Okay, so what we have seen, actually yesterday we have already seen that with breaks, and no new things here, no same thing as yesterday a bit. So again, if we see something you have seen yesterday, it's normal. It's perfectly normal. It is good to review that. Um, in Apache, yeah, Spark pools in Synapse. Okay. So a common use case for using Spark pool in Synapse is for transforming complex data structures using those data frames. Those data frames will help us to get, let's say, rid of the complexity of some data structure. Okay. And why? Why are we now talking about that? Because complex data types are increasingly common and really does represent a challenge for us as data engineers to analyze nested schema and data arrays. Okay, and it's time consuming, really time consuming to do so, and you need to put in place complex SQL queries. Okay. Uh, on the other side, and moreover, should I say, renaming or casting the nested column type data type can be also very difficult, right? Um, the performance, therefore, is affected when you work with nested objects. Let me just give you here a small representation of what I mean. Nested objects. So as it says, for instance, you have your object here. Let's put a square, right? And these represent, for instance, my whole data set, right? Within this whole data set, I have those objects here. And well, there will be like maybe thousands of hundreds of thousands of them, right? That's perfectly normal. But each object here contains many attributes. And those many attributes can also contain over attributes and so on. So the hierarchy here can be quite complex, can contain to, and more than that, when it's not structured or semi-structured, it's actually semi-structured document like JSON. This is a very typical example of JSON. It can have a similar hierarchy, but not the same hierarchy. You can have another hierarchy because, again, let me tell you an example here. With a customer one, customer A, and customer B. So let's say in a normalized database, you would have, for instance, name, last name, first name, last name, phone, email address. But if I'm in a semi-structured data, I definitely have name, last name. But for instance, not necessarily an email, but here in this case, let's put it here like names. Okay. And customer A, for instance, has an email. That's good. Then you have the value, right? And that here names. But for customer B, I may have definitely I have the name or the names, last name, first name, but no email, but fax. Okay, that's what can happen in a semi-structured data. You don't have the attribute email. So that's why the hierarchy, the nested information here would be different. Or another good example would be with address. Suppose that with customer A, he's living in a country as United States. So for address, you have nested here, and let me put it here, state, because it's a federal state, right? So you have states within this country. Like in Mexico here also you're gonna have states. But customer B actually is living in another country that doesn't have states. And therefore, it has, for instance, provinces like in Canada or regions like in France, right? Or any kind of over administrative name. Or maybe they don't use actually this level of administrative. Then you just put the street straight away and the zip code. It can happen actually. I know in France you don't need to specify the region where you are. You go straight away with your street name and zip code, and that's it. You don't need to specify the level of where you are on the region level. You don't put that. But here in the United States, yes, for instance, right? So that's why the hierarchy can be different, and you use a JSON file for that cases. But then you need to undo this hierarchy and put that in a proper matrix, in a proper table, right? With normalizing a bit those information, right? So that's here the whole complexity and the challenge. So first, to do that, you're gonna define function flattening. Okay, you're gonna undo all the data that you have. This function will be flattening those data you have, and then you're gonna define a function that create a flattened second nested schema from one data frame into new data frame. Okay, so that's where you start here to create a data frame. Let me put it here. You start to flatten your data from JSON file, for instance, but those columns are still containing nested info. So, for instance, it wouldn't be here, for instance, zip code yet, but address. But address is done of over fields, over columns. So still have to expand this column. It's not done yet, but it's a second level. It's actually what may happen for those who are working with Power BI when you are importing some type of data that are nested. You will have the option when you connecting to those data source to expand the data that are nested into from columns, right? So that's the second step. And finally here, well, not finally, the first step is to explode those arrays. The one I have just done there with those plus signs, you explode those ones, right? So you will transform the data array from the data frame into a new data frame. Okay, it's another one. I've been here doing this, right? With those columns still nesting information. So you still need to explode those. So by clicking here, let's say, boom, it explodes that column. By clicking here, boom, it explodes. Then you have another data frame, another table with those exploded info, right? So at the end, that's what you're gonna get, a flattened child nested schema, okay? And that's how you need to work with those complex data structures when you have JSON files, when you have other type of files that are nesting information. Okay, 4 steps. You define a function, you get those, let's say, nested object into a data frame, you explode the data frame arrays, and then you get your flattened data frame. I hope this was a bit clear for you guys, so you understand here the purpose at least, or you grab here the whole, let's say, yeah, the purpose. Let's move on, and we will almost be done with this module. So we're gonna talk about here integrating SQL and Spark pools in Synapse. And should I remind you, Synapse is something done, for instance, very well appropriate for a data warehouse. Okay. So again, here we have a way of integrating the SQL Spark pool in Synapse Analytics. So you need connectors, right? So first thing first, whenever you work between different components, you need connectors. And one connectors that are being used a lot are JDBC, which means Java Database Connector. Okay, and it's a good method at some point, but but you're gonna experience some bottlenecks, right? So you have here the first approach using JDBC, and we're gonna need to provide a solution here because uh, the transfer of data between the Spark pool and the SQL pool uh, doesn't actually leverage the distributed systems as it could be. So we stand to have some bottlenecks with serial data transfer. So a new approach can be done, and you will have here actually including a Synapse Spark pool to Synapse SQL connector as a data source implementation for Apache Spark, right? It uses the Azure Data Lake Storage Generation 2 and Polybase capability. So let me show you here. That's what we would do to make Spark reads data in parallel. So we will use this data lake that we have. Um, and therefore, we're going to efficiently transfer data between the Spark cluster and Synapse SQL instance. Okay. So it's also possible to write a data frame into a dedicated SQL pool using those Pi connectors. Okay. Uh, but yeah, you definitely need to create a data frame, for instance, in this case. Well, not on the at that point already, but that's basically the high level view about how you can take advantage of the parallel distributed architecture so you don't experience those bottlenecks you can do with GDBC classical standard way to do that, right? Um, yeah, I guess that's what you need to get out from this schema, right, from this diagram. And now let's talk about writing data, right, in the pool, in the dedicated SQL pool, something we have seen previously. Um, Here, we want to use actually some connectors also. So you write data from that from to table. You create a temporary view for top purchases. A view is very useful when you want to reuse the query you are doing. Okay. And that's in a notebook here, actually, right? So you're using here a Spark here, data frame, Spark framework. So you have your data frame here, Spark object when you take the SQL context, .SQL, because you are in the Python language. So in SQL, let's select stars or everything from top purchases, and then you write that using the SQL analytics method, right? That you have created here with top purchases on this data lake here, using the argument constants.internal. But writing to dedicated SQL pool is quite straightforward. When you take your data frame, you apply the method write. Okay, here we go with some analytic SQLs. Questions. All right, question time, question session. What is an element of a Spark pool in Azure Synapse Analytics? You can answer definitely in the chat. Or you can just think about, give you a bit of time, think about an element. What does that mean first? An element of a Spark pool in this context of being in Synapse, right? But it doesn't matter, it can be in Databricks. How you call that element in Spark pool? And the answer is Spark instance, okay? Any element you're gonna create in the Spark pool to run, runtime, etc., would be Spark instance. Second question, how can all Apache Spark notebooks in Synapse Studio be saved? Now we haven't be very, let's say, we didn't review all the functionality of and then all the GUI elements in Studio, Sign Studio. But just to give you the answer here straight away, sorry, there will be a button there when you want to save your work. You're gonna have to publish it. Okay, publish all actually. It's gonna be there on your workspace command bar. So in signups, publishing means saving, or vice versa. And finally, third question: when is it unnecessary to use import statement for transferring data between a dedicated SQL and a Spark pool? Again, I'll give you a couple of seconds to think about. So transferring data between a dedicated and Spark pool, what don't you need to use as import statement? And that's something also a bit technical maybe, but uh, you need to later on check on a bit any let's say capabilities you need or any libraries or framework. So use the integrated notebook experience uh, to avoid any importing statements. So indeed, the notebook, another benefit as I mentioned, well, it's the same benefit as I mentioned actually. You don't need to change the environment, and that's what I was meaning here. So therefore, you don't need to use import statements, right? When you're gonna transfer your data between those two, for instance, pool, a dedicated SQL and a Spark pool. All right, people. Now, later on, after the second module of today, after the module 6, you'll be able to get into the lab, making a couple of uh, tasks over there in the lab. So you can explore data, transform data, load that, we're working, playing with Parquet JSON files, getting the queries, and seeing some hierarchical structures. So you will use Apache Spark in signups and see and how can you load that into the data warehouse based in the data lake, right? It's dedicated SQL pool, okay? Some objectives for the lab. Again, I will not dwell on those questions of the lab. And what you have learned here about more is about synapse analytics on the side of getting data into the SQL pool from Spark pool, and especially with notebooks. Uh, Again, we talked about data frames, we talked about integration, and a bit of what is Apache Spark and its architecture. Remember, distributed architecture, okay? Do not hesitate to go and document yourself. Document yourself, guys, because there is a lot to learn about. This is big topics, big things, lots of. I mean, just to learn what is synapse as per se would take a whole course, right? To understand all the things. Here, this course is to give you really the overview of many components within your data engineering environment. So that's why we cannot go, unfortunately, into or diving deep into all the elements that are populating this course. And therefore, I'm gonna give us maybe 5 minutes of break, right? Because I know sometimes it can be a bit key to process the information and also give the opportunity for those who wants to get for a coffee break to get those. So gonna put here a time uh, down countdown timer and 5 minutes, guys. I guess would be enough. Just a sec. Let me here put that. Okay, yeah, perfect. All right, people, getting back. Hope you enjoyed this little break. Getting the coffee time, tea time, maybe some snacks. Always helpful when our brain is processing lots of information. It takes energy, right? It takes a lot of energy actually. It reminds us of our maybe student times, right? When we were students, and well, people used to say like, "Oh well, I'm not in the age of learning anything more. It's a bit hard for me now to assimilate and getting new things." And just getting this little parenthesis about this subject matter. Let me tell you, I read a very, very interesting book, Deepak Chopra, I think, about the brain, and this neurophysicist or neuroscientist, sorry, was telling very interesting information that our brain is actually not what we think it is even more flexible than we used to think regarding getting new information. It really depends of how we feel, how we our mindset is set, and the limits are way beyond what we think. And like maybe like 50, 60 years old and thinking that no way I can change my mindset, learn new thing. Actually, Deepra said, no, you can. It's just because you don't want to, right? That's actually a whole point over there in this book, and I really liked. And I said, wow, changing my perspective about many things, about what I can achieve, maybe what can I learn. And yes, guys, to make a point here, don't worry, you can do that. You can learn those new things about cloud computing thing, for instance, here, right? New technology, new paradigm. We are in this era now of big data, cloud computing, and supposedly we're gonna go even deeper than what we think about today. We're thinking we are living in a crazy world with lots of now technology, layers of technologies separating us from the real world. Should we say? Uh, they used to say now you haven't seen anything yet. It's gonna be even way deeper, right? About what's going on with the virtual experience, etc., etc. But anyway, that's a very interesting topic. We cannot expand, unfortunately, now on this. So let's get back in our matter here, talking about Azure Data Factory. Data Factory. Oh, like, are we gonna produce more data? Well, the name is a bit maybe not so self-explanatory, but what we mean here, or what Microsoft means by data factory, is that yes, in some way you're gonna work and produce, do something on data, but you definitely do on some material, raw data, as in a factory, right? In a factory, you need first your resources, some raw material, right? You get those raw material, like I don't know what you are producing. For instance, some steel, yeah, some steel, some any raw material you can have, and then you process that in a machine. Some couple of things are happening here. Lots of smokes and everything are going out of this, and then you get some product. Oh wow, we produce something here. What we mean here is almost the same, because we are getting, in our analogy here, some raw data. Yes, those raw data are gonna be get into a pipeline, right? We have seen this term yesterday, a pipeline. So here is our pipeline. And at the other end of this pipeline comes our, should I say, clean data, or maybe analytical ready data, whatever whatever term you want to employ here, something that are ready to consume, right? Ready to consume data. Could be analytical, for instance. In our case, it's gonna be analytical context. And talking about that, I'm gonna also give you here a quick, and I'm gonna open this quick parenthesis about data warehouse because that's what it's about here. Um, we are getting some data that are in usually in a transactional context. Okay, transactional context means it's those databases that are in place where they're updating constantly, getting new rows, getting new data constantly from your business, from your day-to-day business operations, like registering the sales done, any actions that are meaningful for the business, anything that you need to get somewhere and save what's going on in your business. It can be like cancellation, for instance, it can be like customer complaints. It can be many things according to the business where you work. It can be any data monitored from any devices that you're taking care of that are crucial to business. So many kind of data are gonna be stored in your transactional database. But guess what? And it happened to me actually as a young and junior data analyst, or wannabe, because I was a business analyst, but get into that field, I needed to create a dashboard for my director board. And what I've done at the beginning is, okay, where are the data? And then I talked to the IT guys. Yes, it's here. This is our relational database. Look, our tables. Wow, it's a bunch of tables. Okay, so I'm gonna need this, and I need to process those queries. Okay, those queries, I didn't mention as that, but our analytical queries, and therefore I needed the this relational database management system to overload with my analytical queries to get that in some interface that I was creating for my dashboard. It obviously takes some resources, right? But more than that, it started to be very heavy. I mean, in terms of workload, it takes lots of resources and it started to affect the business, right? And it was not good. So that was not the way to working. As soon as I started to think and said, hey, there are things like data warehouse, some people was talking about, I was actually talking about this matter and somebody mentioned data warehouse. That's where actually I start to get aware about data warehouse and etc. So that's they tell, yeah, data warehouse is something you need when you do analytical workload because you cannot query directly from a database, transactional database. It's not possible. It's not efficient unless it's like very ad hoc queries. Again, like now and then you need, but here no. Here we are talking about the dashboard, a proper dashboard where it's gonna be consulted maybe on a daily basis. So you need to create a dashboard, and to create a dashboard, you need an ETL process. What I've just explained here, and an ETL process is that process that we're talking here. And the pipeline in our ETL process is getting those raw data from a transactional database, and you need to work on those data. You cannot just take this data and replicate another database as it is. It's not efficient. We have seen in this industry some best practices getting into the schema. All right, star schema is something that you want to do when you are getting into your data warehouse. And it's called a star schema because your tables or your architecture here looks like should look like a star, right? So that's what you want, and that's what you're gonna need to consider when you are feeding your star schema with an ETL process with, for instance, here a factory. Okay, this is a bit a long introduction, but it's very important for you to know, to understand why we are talking about a data factory or Azure pipelines. What for? Where are we going with this? So that's basically the why again. We need our data warehouse to be not only created but also updated and be feeded and updated at any time you need. So your dashboard, because that would be making your final dashboard here with your graphs, with your visuals, right? With your pie charts and your column charts, right? And any statisticals that your boss would be happy with. So yeah, this needs to be updated, right? It needs to be updated. If not, it doesn't provide any value, right? So that's the whole process here. What we need, what you care about at the end is this. Obviously, that's the final value. But this is something that needs a big architecture here, like a data warehouse. And this data warehouse, well, needs this ETL process. So the agenda would be quite actually short. That's why I'm also getting this. I'm getting this opportunity to talk about more about what we are doing here. Integration with Azure Data Factory or Science Pipelines, what it involves, and especially when you do that, you can make it code free. You don't need to code anything. That's good. Good news for those who are not so comfortable with coding. So don't worry. Those transformation with pipelines that you're gonna see are code free and they're at scale, right? We're talking with big data again. So let's get into the first thing. What means data integration with Data Factory? Okay. So you're gonna have um, several elements that we have already seen yesterday, but again. I'd like to come back to the data warehouse concept, and so you definitely get that maybe into your mind, and no doubts are there. So a data warehouse is made of tables linked together as in a database, relational database, right? So you're gonna have uh, a big table. Actually, let me rephrase this table. This table would be actually like this. Well, no. So what I'm doing is gonna be more like this. Let's continue. And not so large actually. Well, it shouldn't be, but depending on the environment where you're working. So this is a big table with many rows. Why am I making so large here? Because usually a fact table is a table where you're gonna put all the facts, all the business events. A very typical example is sales. All the sales, all the transactions are gonna be feeding feed it here. Okay, but that comes from a relational database, right? All the cells here. And usually the rows are about in big corporations, in big companies. We're talking about even billions, billions, well, again, billions of rows, right? Especially if you're taking like you have some history, like you have many years of of data, so then yeah, it can become quickly a big fact table about billions of rows. And this table will be actually linked, there will be a relationship with what we call dimension, dimension table. Okay, this dimension is useful to actually make sense of this fact table because we want to analyze, we want to have an analytic uh, thought about those facts. We, for instance, dividing my cells by years, okay, by month, by quarters. So the time dimension is something very, 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 and I should say even mandatory. You're always gonna have timetable. Then you can have another questions. You can have other questions. For instance, what about my sales per product, right? What products are the best in my company? What are the best sales per product, per subcategory products, etc. So you're gonna have a dimension of product, and it's gonna list here all the products you have and sub product. Other question may emerge about another dimension would be, for instance, what are my sales per region, per countries, per zone? So geography, for instance, geography area, something like that, right? So another table. So those tables of dimension would be there to describe and to provide you some, let's say, description, some sense of your analytical fact table cells here, right? And those tables are not so big. They can be big, actually, relatively big when you are a big corporation, but they are definitely not as big as this fact table, okay? Anyway, my point here is you need to always feed those tables with a pipeline, the kind of pipeline which would be this ETL process. Sorry, not this one here. That's not the here. Another, it's an external flow of data that come into those table. The dimension are here updated also, right? We're talking about slow changing dimension actually. Slow changing dimension. You have different type of slow changing dimension. A slow changing dimension means that, and on the contrary of the fact table, which is changing constantly, well, at some pace, right? At some pace, like every week, every day, depending on how we are feeding the fact table, right? The ETL process here, is it like on daily basis, on monthly basis, etc. This, for instance, if this feeding flow is like on daily basis, this maybe would be on monthly basis. Like every month we have some update about the product because our company is not releasing a product, a new product every day, right? Maybe, well, depending on the industry again, but usually in the industry that you know, you create a new product every year, should I say, or every 6 months. Well, we are more in a more fast changing world today. So yeah, maybe every 6 months, every quarter, you have a new product emerging. So your dimension table about your products will be updated, and you have different kind of way of updating your dimension table. Okay, there are type 1, type 2, type 3, etc. I will not go into this subject right now. What are the different, what means the type 1, what means type 2, type 3. Just keep in mind from now on that you're gonna have to update your dimension tables anyway, and there is some methods to do that. Different methods. Like here you can see 3 different methods. You don't say, I will not tell you again right now what means those type of methods, but just keep that in mind, okay? our fact table will be feeded, and it's gonna change, it's gonna grow constantly. Also, our dimension tables will be changing and maybe growing a bit slower, but it's gonna do anyway. So to feed all those tables in my data warehouse, I need the ETL process, and therefore I need my Azure Data Factory to do that, right? All those, uh, let's say, big arrows are those Azure Data Factory pipelines or the endpoint of those pipelines. So let's have a look to get into the place this uh, process of ETL. First thing first, you need linked services in Azure Data Factory, Synapse pipelines, and they are much like connection string. And I mentioned that, I guess, previously, because it's something we have seen yesterday, but I'm gonna repeat that again. Connection string. So that's what they are. Connection string is, as it says, something to connect two elements, right? You have two elements, whatever elements there are, we want to connect them so they can exchange data, information, and there is a string like you're gonna put a name, right? Well, here in this case it's a string, right? But this connection string would make this link, and it's a service, just here called as a service because it's quite complex to implement that on the back end. So they define the information that's needed to data factory to connect to external resources in this case. Right? You have your data factory here, and we want to connect to many other external resources. Okay. Um, and that's it. You have to represent that as a actually something that gets the connection, and as in over any other database connections you may have seen, right? Then you have, well, within the linked service here, you're gonna have, whoops, sorry, I've been a bit, yeah, here we go. So you're gonna connect data lake, for instance, storage. That's the first thing you would like to do within Azure ecosystem. You're gonna have a storage account, and normally, as a good data analytics person, you want a data lake storage, and more than that, generation two, right? As we have seen. So you're gonna connect that to your data lake storage, and you might probably would like to connect, for instance, your data lake storage to Azure Databricks, right? Um, that's the first element here. Then you're gonna have data sets on the other hand here, right? You want to have your data set, and it represents a data structure within a data store. So you have here your endpoint in our data warehouse, uh, uh, this data store that we want to feed. And it's really like a reference to pointing to data that you want to use at the end of your, as an output of your activity, right? But in between then comes, and remember we have seen already this schema, this activity process, right? For instance, that can be copy activity, and I think we have seen this copy activity actually from this data source to your data set that you want to have here. I'm not telling this data set should be for instance, fact table or the dimension table, but it could be like a staging table where at the end you're gonna just replicate your data set to the final destination. Okay, so it depends really on your architecture, but uh, it depends. It really depends. It can be the final destination, or it can be just an intermediary stage or place where you're gonna at the end use this data set and get copy that in your house Data warehouse can be actually also an intermediate between the visualization of your data and your, let's say, data that you have there, analytical data. So yeah, uh, one thing in all, you have your activities taking place uh, from the data source, right? You take those data and you process them through a pipeline. And these pipelines, in our context, means not just a tube or how you call that, a bottleneck, right? But it's really more this. There are like threads, like runtime environment. Some processing is happening. A pipeline will be like a program, yeah, a program that is performing action on your data. For instance, one of those can be copy. Another one could be, for instance, select some columns, or on the other way, to rephrase that, drop some columns we don't want to take, or just select my data where the customer is equal to A. So I'm not taking all my data there. I don't need. I'm just considering my customer equal to A, my customer A. I mean, this is not very common here because we don't want to consider all customers, but just an example could be like selecting maybe data, my rows, where it is actually not new. Okay, for instance, just a way of cleansing your data here. I don't want any null rows. Okay, and there is another way. I can actually here work on those null rows. When you have null rows, then I want to replace null with, I don't know, zero. I mean, it's really, really arbitrary here. It's very simplistic way here to see things, but that's the philosophy here, the mindset. You want to transform, you want to clean data, you want to do, and what I'm mentioning here is basically this. Cleansing means this. You want to get rid of null value, you want to replace those value with something. Cleansing means also, for instance, again, replace, for instance, the string C, let's say CSTMR. I don't know. It's very like something that doesn't make sense. Right? With customer, with the string character customer, because we don't want to have some doubt, or there is one rule when you are visualizing your data. You have to have friendly data, friendly names, etc. That's something you can see when you take courses with Power BI, this data visualization tool. And you need to make some cleansing data over there also when you get data from even from data warehouse. Sometimes you have some not so friendly uh, naming columns or things. So you want something clear, you something nice, and then you need to make those cleansing thing, right? So that's what pipelines can do also. Pipelines will do some couple of things here to copy, to select, to drop, to replace, etc., etc. And obviously, as we have seen yesterday, it can be triggered. So that means you don't have to sit behind your computer over there. Imagine there is this place where you are working in, and there is, well, your business activities takes place every day, and at some point you need to take care about how to update your analytical store, and you decide to do that every day at, I don't know, 12 o'clock, right? But it's not so efficient. And imagine if you are not here, or if something happens, or then you cannot just rely on making those updates or checking out on manually. So that's why triggers are used and to be more efficient, right? You can program that. So you're gonna place triggers. So like threshold, for instance, scaling 12, I'm gonna load all my data here from this place of the data lake to this pipeline. This pipeline will take this process. Okay, we'll take those columns, replace those values, and put that in this data set frame here, right? And from there, you can have another pipeline doing another thing and putting that actually in my fact table, right? So many possibilities here with the, and let's say data factory architecture. Pipelines can be very complex, can have many pipelines, many activities taking place in certain order, in a certain sequence. So that makes sense for your business. And the trigger is actually triggered, and then your pipeline is working, right? So that's here the whole point. And the data are flowing from the data source to your data set. Now, interesting things that I mentioned also yesterday, and again, parameters is also very useful when you need to uh, change a bit your pipeline depending on maybe which data source it is. So that's very useful method here to not rewrite or re-implement a brand new pipeline because it takes resources, it takes time, it can generate errors if you're not doing properly. So parameters are very good method to a good way to actually reuse your pipelines to module your pipelines, right? Integration runtime, where you want to run your pipelines, which environment in the cloud, public cloud, or on premises again. Maybe I haven't been clear on that point yesterday, but running your pipelines in the cloud means, in the public cloud means that the security is taken care of by Microsoft over there, and running that in your on premises means that you are responsible for the runtime, the environment over there. Integration runtime is referenced by the linked service or activity you are doing. And as I mentioned, is something that provides the environment, the compute environment, okay, where this activity of your pipeline can take place and where it's gonna get dispatched, right? So actually, there are three types of integration runtime, okay? So the one we have seen, we have the one which is, as I mentioned, in the cloud, in the Azure cloud. So you're gonna copy, let me put it here. You have the first type of integration. So here, let's see here, 1, 2, and 3. First one is the one in the cloud with Azure, copying between two clouds of two cloud data sources, right? So one source is here, another destination here, and the integration runtime is over there, right? The other one is self-hosted, as I mentioned, so the one on premises, so in your company, right? Should I maybe draw here a little building? Your building work, and here are the databases where you are storing all your servers. So the integration runtime takes place at your locals, right? And the third one I haven't mentioned actually is something called, and you can use the Azure SSIS, SQL Server Integration Service. And I will just spell it here, integration service. SSIS is a bit like the grandfather of the data factory. You can actually see that when you use SSIS, the interface, the ETL process was actually done after the cloud era. with the Microsoft SSIS service. It's really this service that actually provides the ETL capability, right? Today, now we're using Azure Data Factory because we're on the cloud. But before the cloud, we use SSIS. That's just what you need to remember. And since many companies are still using SSIS, Microsoft need to integrate still to consider those who are still using SSIS. That's why still providing an integration runtime with SSIS. Okay, so that's what you need just to remember here. There are those three integration runtime, and well, depending on your environment, you're gonna use one of them. The control flow, what should I say about? Well, you're gonna see and you're gonna use control flow. It's actually an orchestration of all the pipelines activities, right? That are chains in a sequence. There are branching sequence because pipelines can be very complex and it can go from this point when you have your data source here, it can go there, then from here, depending, did it actually fail? Because you can set condition. If your pipeline here, if your activity fails, then you can go there instead of there, right? So you have some branching. That's something you can see, you're gonna maybe see in your lab when you use Data Factory. You're gonna do branching. You're gonna set if, if fail, if it doesn't go well, so we go here. But if this activity here was successful, then you go there with this pipeline, etc. So that's one thing with the control flow here, as in programmation, as in coding, you have your control flow saying your if conditions, right? So that's what you can do. And as in programming or coding, you can have also your, let's say, loop, right? You're gonna loop your activities as many times as needed. You're gonna do that, boom, 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 and at the end, you're gonna go out and go to another, let's say, sink or another destination with this pipeline here, right? So control flow are basically giving the possibility to make complex pipelines, or let's say a system of pipelines to get your ETL successful, or at least what you need to do, right, for your business. Now, here's an example, some screenshots about how it looks like. Okay. For instance, if you are working within the Azure portal, which is the one I recommend, the GUI, you can still work on the other interfaces like the command line interface, the Cloud Shell interface, but they are very like for people who knows the command lets, and very powerful, right? Powerful. But at the beginning, when you want to get formalized, go on the portal and start to look for instance, here the Synapse Analytics workspace. You go on here, linked service, okay, linked service, and then you can create here a new linked service. That's the first step. And for instance, your database that your organization is using, that you want to get the data from, is Azure Cosmos DB, which is quite cool. It's a cool one because this one is getting you some even unstructured data. It's another topic. But anyway, you want this one. You want to get data from Azure Cosmos DB. So you click on this icon and you just continue. And then you're gonna have here some information to enter. So a unique name, you can put description. You have to set a connection string with the Azure Cosmos DB account name, with the database name, and then you can test the connection to be sure that's what you've put there is correct and that your database is reachable. So finally, you're gonna create this linked service. Then you want to create your data set. Okay, so again, where you want to have your new data set to integrate. So you select that. If that destination would be again Azure Cosmos DB, you select that. And then again, you have to provide the information needed. The linked service, now you're gonna link your data, let's say data set destination with the linked service you have created previously. You can provide here a collection name. And finally, you're gonna uh, click OK when you're ready. And finally, well, almost finally, you're gonna we're gonna here enter into what we were talking about, the activities, the proper pipelines that we want to create. And you're gonna have many choices in Azure Data Factory, as in Synapse pipelines, between copying data, between selecting, etc. So here is an example. Import data from this point, renaming. You see, we're gonna here making some, let's say, cleansing or transformation activity. So we are renaming, for instance, here campaign analytics to map campaign with columns. We're gonna select those columns. Okay. The good thing is very little description of what each activities are doing. Right. You can get into those activities with here the plus sign actually. Right. So at the end, it's gonna be exported this uh, in this yes, in this synapse here pool. And to create a pipeline, you need to be there in development section, integrate, and you're gonna click on the plus button here. You have straight away just a straight copy data tool, right? When you just need to copy, because it can happen it's quite common to just copy data from one point to another. But what you want sometimes is just a proper pipeline with your custom operations or activities. So that's why you need to click pipeline. And that's where actually you're going to start to select the kind of activities you want. It's going to be all the activities you're going to have at your disposal will be organized by the type of activities: move and transform, copy data, etc. So you're going to have to choose from the type of activity the one you want, and you just drag and drop. Drag and drop. No code. You don't have to declare anything, import anything, typing a code, barbaric coding there. No, you just, it's designed in a very friendly manner for you guys to design your pipeline. So you just drag the activity and drop it. This here is the activity of copying data. You see, it's like in this rectangle here with some free, let's say here, lines. So that means you can click on it, you drag it, and you drop it. That's it for this part of this module. We're almost done. So now let's talk about the code-free transformation at scale. And that's actually the continuation of what we've been talking here. So again, we have here an example of a pipeline. Okay. And here we talk about data flow mapping. Okay, it's like we're definitely mapping a data flow. And they are visually designed here. It's the same in Synapse pipeline, right? And here, this data flow allows data engineers to develop graphical data transformation logic without writing code. Okay, that's what we have actually been doing here. And the resulting data flows are executed as activities within data factory pipelines. Okay, and they use scaled out Spark clusters. Okay, scaled out means that way. Scale up means that way. Okay, again, let me show you here. Scale up like this. Scale out like this. Scale up in cloud computing language means you want to increase the memory capacity, the compute capacity. Like I have 3 gigahertz, now I'm gonna have 4 gigahertz. I have 32 gigabytes of RAM, I'm gonna have 64 gigabytes of RAM. That's scale up. Scale out means I'm gonna just put another CPU, another RAM, another virtual machine. I'm gonna put another virtual machine. I'm gonna put another, in this case, for instance, another node, right? So that's for you to know. Just giving you some tip. What means up? What means out? Scale up, scale out. Okay. Um, Okay, your data flow will run on your own execution cluster for scale out data processing. Azure Data Factory handles all the code translation, path optimization, and execution of your data flow job. Okay, so the data flow mapping brings the following benefits. So we have performing data cleansing. Okay, again here, yeah, data cleansing. That's what we have been talking about at the beginning. Focus on business logic. So you don't lose time building business logic. You don't lose any time with any technical aspects of trying to make the connection, the integration. And integration is a big deal, actually, in those kind of architecture. You know that any person that was working with some big ERP system or any big system, I used to do that actually within public transportation, where the system is so big, so huge that integrate any new element or making it work. Wow, that's actually a whole work of a business analyst, system analyst, when you need to consider any requirements, constraints, well, lots of things there. But here it's so well done. I mean, it's done in this way that the you just have to be focused on the value of your pipeline, not any other thing, right? Um, and and because actually, and because the underlying infrastructure is provided, you don't have to take care about that. Underlying infrastructure provisioned also, right? Automatically. So that's some benefits of using Data Factory or Synapse pipeline, okay? So for instance, let's talk about adding a source. You get here a source from Dataflow debug, right? And you're gonna specify setting first. The output stream name, the source type, where it's the data set or inline data, the data set path, and some options, right? I will not get into the options details, sampling, etc., because those are something that are more advanced, and at this stage, you don't need really to get everything. You just have to know that you first need to set the source with a name, with a path. Um, then as soon as you get your activity, you can select what you want to have the next step. Okay, so clicking like plus, you can derive or you can select the next step. So when you derive the com setting here, you're gonna put an output stream and an income stream, right? So what you want to do, for instance, for the transformation of this column is on this column revenue, I want to perform that activity here. So here, when you perform those kind of activity, derived column, it's gonna require you sometimes to know a bit what expression means, how the expression is actually built. To decimal, we're gonna replace with concatenating and putting that in stream the revenue part one, for instance, right? You can flatten actually your data with those kind of transformation. And finally there, you're gonna have multiple input output transformations. So you can join and joining have to select the type of jointer. You can actually filter the rows. That's anything I've already mentioned about the cleansing transformation. And you're gonna have those options to provide when you use one of those transformation activities, or put in a sink, right? And then you can filter there. So I will review here, quickly review the question. You are moving data from Azure Data Lake to Azure Synapse Analytics. The runtime where you would use it is the one in Azure, because you are in the Azure cloud. Quickly, which control activity can be used to bridge an activity on a condition that evaluates to true or false? And the answer is the if condition activity. Okay, and that's what we have mentioned, the branch. Finally, what feature enables you to interact with the mapping flow transformation you create? And the answer is the debug one, when you're going to be able to get more into the mapping data flow that you want to fix. Okay, so now we're done with this module. I hope I provided you here the most important insight, and therefore you need to develop, you need to take care about the following, the follow-up, whether it is on Microsoft, Learning Path, web page, or any other kind of source you have at your disposal. It's a really term, mid-term, long-term work on that subject, right? And the lab, please do the lab as you can, because the setup, I know, is a bit sometimes difficult here, but as soon as you have set up, then you can go on and thank you very much, okay, for your time. And well, if any doubt later on this module, please let us know. We are here to provide you with help. Thank you very much again for your time, for your trust, and I hope this was useful for you guys. I'm gonna see you tomorrow. Thank you very much. Max Living.